In the last video, we had discussed about a magnetic field produced around the conductor. We'll repeat this in this video too. Current carrying conductor produces magnetic field. Shape of magnetic field depend on the shape of current carrying conductor. In this chapter, we are going to discuss about three different shapes of the current carrying conductor, and that is a straight wire, a circular loop and a solenoid. When no current is flowing through the straight wire, there is no magnetic field, and when current is flowing through the straight wire, there is a magnetic field which looks like a concentric circle centered around this wire. So you can see here there are concentric circles and the center is the wire. So the magnetic field produced, or the shape of the magnetic field produced around a straight wire, looks like the concentric circle centered around the wire. Here the current carrying wire behaves like a magnet. The current carrying wire behaves like a magnet, hence it is creating a magnetic field here. Have you observed any pin getting attached to a wire when we charge our phones? The answer is no. This is due to weak magnetic field. For a strong magnetic field, we need to pass a high amount of current through the wire. That is, magnetic field is directly proportional to the current. Now, do you know how does the magnetic field change based on the distance from the wire? The magnetic field strength is inversely proportional to the distance from the wire. That is, greater the distance, bigger the magnetic field. There are two things that we can remember here. One is that if we pass a good amount of electricity or a good amount of current, the magnetic field created around the wire will be very stronger, and the magnetic field will reduce as it is away from the wire. So if the greater is the distance, weaker will be the magnetic field. The direction, how can we find the direction of the magnetic field, that we have learned in our last video itself, and for that we are using the right hand thumb rule. In that we learned that the thumb indicates the direction of the electric current and the folded fingers shows us the direction of the magnetic field, in which it is either clockwise or anti-clockwise. In the same experiment, if we change the flow of the current also, the direction of the magnetic field will change. So depending upon the direction of the current, the magnetic field direction will change.